Hi everyone. How are you guys doing today? Fatima, Su, Tao. I'm doing fine. Thank you guys for asking. I'm doing great. Alhamdulillah. It means all praise to God that you are doing great. Hi, peace. And Queenie, Layla. We're almost done with the semester. I can't believe we have only few more days. So, as you know, our exam 2 is on Monday. And exam 2 will be based on 9, 10, 11, 12. So, before we start the lecture, any question, comments, concern, complaint, thoughts, anything from any one of you? Or anything outside of the class you want to discuss? Nothing? Okay. So in this exam, you're allowed to have one-sided cheat sheet, just like your exam 1. Paper size doesn't matter. You can have any size paper, and you have to have one side blank, and other side you can write anything. I would suggest you to write specifically all the notes I mentioned in our review sheet. For every chapter, I have some notes on the top, just above the questions from the chapter. So make sure you have those in your cheat sheet. And then if you want to have anything extra notes, feel free to add them. And I will give you two questions, 2 parts in one question in chapter 9. Chapter 10, 2 questions. Chapter 11, 1 question. Chapter 12, 1 question. So it's 6 questions, but it's inside 5 questions, plus 1 extra side with other stuff like fill in the blank, true, false, definition, like those. Okay. So let me go over chapter 12 real quick, and then we'll do a review. And if you have any question about the review sheet, you can ask me there. Otherwise, I'm not sure what to do in the review, because I already told you what will be in the exam. Okay. Now, chapter 12, as we mentioned in our last class, it's talking about chi-square. And chi-square has 2 scenarios. I mean, it's 3. There are 3 cases where we use chi-square. But in here, in our class, we are going to introduce, I'm going to introduce to you 2 cases where we use chi-square. One type of test is goodness of fit test, and we do it on 1 variable from 1 sample. And we decide if 1 variable is likely to come from a given distribution or not. For example, we may have some data on some people based on 1 variable, and we may have their proportion from another source, like population proportion from another source. So what chi-square does, it tests the proportion we got from the population. Does it match with the data we got? And here our degree of freedom is number of categories minus 1 means number of rows minus 1. Then we have second type of tests, is the test of independence. We are working with two variables and we want to see whether the two variables are independent of one another or they have some relation. And in this case, our degree of freedom is each category minus 1. So row minus 1 times column minus 1. And we do the same thing what we did for z-test and t-test. First, we need to find some type of test statistic and then critical value. We compare them and then we see what conclusion we can make. Do you reject or fail to reject the null? And one of the conditions to apply chi-square is that all the expected count must be bigger than 5. Expected count means our size of the sample size times population proportion for each group. If all of these are bigger than 5, then we can perform the chi-square. Also, the sample we are working with, it must be a representative of the population or a random sample. And in our last class, I was showing you a different example, but today I want to start with something easier to understand. For example, this one. We have a movie category with movie genre are action, comedy, horror. And we asked 200 people what they like, which of these they like. So among these 200 people, 120 says they like action, 100 people say they like comedy, 80 people says they like horror. On the other hand, the population proportion we got from some type of study, we learned that 45% of the population like action movie, 25% of the population like comedies, and 30% of the population like horror. So population proportion means based on the population, what we observe from some type of study. And frequency is the observed count. It means in our sample, how many people fall under each category. Now, we want to see that do people prefer some movie genres more than others? Or do they like all genres equally? So obviously from this data set, you can see that not all the movie data are same. Okay. They're like the distribution of the likeness of each genre are not same. It's different. But we want to be sure, we want to test it. Like, do all people have the same preference for each genre, or some people like action more than they like comedies? We want to test that. So there are some notes I have here. The observed count is how many people choose each genre, and the expected count is how many would be expected if all genres were equally or proportionally popular based on their assumed population proportions. For example, after 200 people we surveyed, 100 people said they liked action movies. So we believe that 20% of overall population likes action movies based on some type of data we have before. Now, if the observed count are very different from the expected count, it suggests that the genres may not be equally popular. And the chi-square test will help us confirm whether the difference is statistically significant or not. We see that they are different, but we want to see that difference we see with our eyes. Is it statistically significant, or it's just, it doesn't matter, like it's not so visible. So what we do is we count, we complete the expected count. We compute the expected count. We have to see what would be the proportion for each category from the sample we have, or probably I should say in the sample we have. So 45% of population like action movies. So we want to see what would be the 45% of our 200. So we do 200 times 0.45. And what is 45% of 200? You guys figure this out and let me write this down. The next one says 25% in general, like comedy. So we want to see what is the 25% of 200. So 200 times 0.25. And the last one, 30% like horror movies. So in 200, how many people supposed to like the horror movie? Okay, so the first one is 50. 25% of 200, 50? No. The first one is 90. Okay. So the first one is 90. Second one is 50. And the last one is 60. So in our 200 people, 90 people supposed to like action. But we found out that actually 120 people like action. And in this 250 people supposed to like comedy. But actually we found that 100 people like comedy. And 60 people supposed to like horror, but we found that 80 people like horror. So we already see there's a difference between what expect to have and what we actually have. Now we want to test the difference we see. Is it statistically significant or not? So in order to do that, we need to fill out the next column. In the next column, we are going to subtract observe. We're going to subtract expected from observe, square the quantity so that we don't have to deal with any negative, and then we divide by the expected. So our observe is 120. We are subtracting the expected. So our expected is 90. We square the quantity and we divide by 90. That should be the first number. The next one, we have observe 100. Oh, you got 10? Great. This is 10, the first one. The next one is same thing. You do 150. So 100 minus 50, square the quantity, divided by 50. And the last one we have 80. So 80 minus expected is 60. We square the quantity and we get we divide by 60. So let me know the number. Whatever number you have, we are going to add them at the end. So let me add this here. The last row is the total sum. So the first one is 10. What's the next one? 100 minus 50 is a 50 square. 50 square divided by 50 is 50. Right? 100 minus 50 is 50. 50 square divided by 50 is 50. What's the next one? The last one is 6.66. Okay, so we add all of them. We got 50, 60, 66. 66.66. So what we got here is the chi-square statistic. So to find the chi-square statistic, we apply this formula. We subtract each expected from each observation, each observed data. We squared the quantity and we divided by expected quantity. Once we do it for every row, we add all the rows, and that gives us chi-square statistic. Because 200 is a total people we have in our sample. So expected count here. Expected count is n times the population proportion for each category. So we have total 200 people in our sample, and based on 3 categories, we have 3 different proportions. The first one was, I forgot, 45. So multiply by 45. Second one, we have 25. So multiply by 0.25. The last one was 30. So multiply by 0.30. That's the expected count. Expected means how many you expect to have based on the population proportion. So based on the population proportion, we expect to have 90 people to like action. But in our sample, actually 120 people liked sample. So liked action. Is it clear, Fatima? Great. So chi-square has a symbol. It looks like X, but it's not normal X. It's a Greek X. We call it chi, and this is a square. So chi-square statistic is sum of all the observed minus expected square divided by expected. So in our case, we found this is 66.67. Now, just like the other ones, other tests, now we need to find what is chi-square critical. So chi-square critical needs 2 things, just like t-test: degree of freedom and alpha level. So in here, degree of freedom is number of rows minus 1. So how many rows we have? 1, 2, 3. 3 categories we have. So 3 rows. So our degree of freedom is 3 minus 1, which is 2. And our alpha is 0.05. 0.05. And in here, do we have 2 till or 1 till? No, it doesn't have 2 till or 1 till. For now, it's all 1 till. But in real life, when you work with chi-square, we have 2 till or 1 till. So we use a different chi-square table. So we have degree of freedom 2 with alpha level 0.05. So degree of freedom 2 is here in this row. Alpha level 0.05. 0.05 is here. So 5.991. Our chi-square critical is 5.991. So we carry out the test and we realize that chi-square critical is smaller than chi-square statistic. Do you remember, if the statistic is bigger, do you reject the null or do you fail to reject the null? Good job. Yep, we reject. So we reject the null hypothesis. Oh, you may wonder how come I didn't do null hypothesis and alternative hypothesis. In chi-square, the hypotheses are optional, okay? Because we are testing something that doesn't require a hypothesis. So by default, our hypothesis is they are equal. So let me write down the hypothesis here. Actually, I do have here. So null hypothesis says that the preferences for the movie genres are equally distributed as per the population proportion. It means, yes, for action, we have 45%, right? 45? Yeah, 45, 25, 30. And for comedy, we have 25%. And for horror, we have 30%. So null hypothesis is saying that the proportion is exactly a population proportion. And alternative says, nope, it's not like proportion. People may like one genre more than other genre. So it's the opposite of alternative. So null hypothesis is false, in other words. So null hypothesis is saying that whatever we have, they're equal. The sample and population proportion, they're equal. Alternative says, no, they're not equal. We have some discrepancies. So in here, we reject the null. It means no, the genres are not equally distributed. So we have some differences. Some people may like one genre more than the other genre. So since you're rejecting the null, it means we have enough convincing evidence at the alpha level 0.05 that the people do not like all movies equally. Okay, some people like horror probably more than the other one, or maybe some people like action movies more than the other ones. So they do have some statistically differences, significant difference between the population proportion versus the sample proportion. Clear? Any question for anyone? No question? Let's do one more. A car dealership surveyed 300 customers to determine their preferred car color. The dealership believes that popularity of the colors matches the proportion of their historical sales data given below. Do customers prefer car colors in proportion that match the dealership's historical sales data, or some colors more popular than others? So here we are finding same thing as before. based on the population proportion, do we have significant evidence that the population proportion is what is given to us? In other words, do people like all the colors evenly, or they like one color more than another color? So we do the same thing. We see how many we have in our sample. If you add all of these, you're gonna have 300 people. So observe will always be given, and the proportion will be given. Either proportion will be given in this way, or proportion will be given using a hint. So if this way is given, then it's easy. All you have to do is multiply our n with each proportion. So the first one is 40% of 300. So multiply 300 times 0.4. The next one is 300 times 0.3. And the last one is 300 times 0.3. So 40% of 300. 120? Is it? It is a 90. Am I correct? I don't have the answer in front of me. Oh yeah, 120. Cool, cool, cool. And then 3/10. So 90, right? The next ones are 90. Wonderful. So to find the chi-square statistic, now I need to fill out this formula. So in the exam, I'm gonna give you the first 3 boxes. You need to fill out the last 2 boxes, and then add the last box to find the test statistic. So observed minus expected. Our observed is 120, so 122. Expected is 120. We are dividing that, we squared the quantity, and then we're dividing by 120. The next one, our observed is 88. So 88 minus 30, we squared the, 90. 88 minus 90, we squared the quantity, and then we divide by 90. Lastly, we have 90 minus 90, that gives us 0. So basically, we just have to find the first two. So the total sum, what do we have for the first one and second one? The last one is 0. 0.03. And then the next one, minus. We cannot have minus because I squared the quantity. When you square the quantity, result must be positive. So you made a mistake somewhere. 0.044. So we have 0.074. And I think this is 0.033, right? So it should be 77. So our chi-square statistic, you must put parentheses because you're squaring the quantity, the whole quantity, is 0.077. On the other hand, our chi-square critical, this time our degree of freedom is same, t minus 1, 2, but our alpha level is different, 0.01. So degree of freedom 2 with alpha 0.01. Degree of freedom 2 is here, alpha 0.01 is here, so 9.21. This is 9.21. So if you observe, this time we have chi-square critical bigger than chi-square stat. So for conclusion, we have, do you reject or fail to reject? Fail to reject. Even though we did not state the null hypothesis, but we assume that null hypothesis is that the proportion is according to what they are telling us. An alternative will be the opposite. So since we failed to reject, so we have convincing evidence at the alpha level 0.01 that the observed preferences of the colors match the expected proportion. In other words, there is no significant difference in the popularity of red, blue, or black. It means people like them equally. They don't have a preference over the color of the car. But in reality, it may not be true. This information, this conclusion he came up with only based on how many people? 300 people. In reality, I think people like black more than red or blue. I think. But this data is telling us, nope, I'm wrong. Based on the 300 people, there is no choices for the color. Whatever looks good, they just pick the color. Any question? Yes. Here, alpha is 0.01. Alpha will always be given. So observe will be given, proportion will be given, alpha will be given, number of categories will be given. The only thing you need to find is expected and everything for this thing. No problem. And so these two example is where the population proportion directly given. Now let me show you another example where the population proportion are not directly given. We are just given some hints. So tau ex for the solution for this one. So let me just show you the solution. So the solution for the question I introduced you in our last class is this. I'm not going to go over this because it's too big. Instead, I'm going to go over the next one. In here, they did not give us the proportion directly. So let's read. The authors of a paper studied a random sample of 352 Twitter users. For each Twitter user in the sample, the tweets sent during a particular time period were analyzed, and the Twitter user was classified into one of the following 5 categories based on the type of messages they usually sent. So IS means they sent information, and then OC means they shared opinion or complaints. RT means they just randomly post their thoughts. Me now, what they're doing is me, and O means other. So these are the symbols which represent these 5 categories. They want us to carry out the hypothesis test to determine, are the group evenly split, or are some groups bigger than others? Okay. So look at the information given to us. They just gave us observed count and then the 5 categories. Category 1, 2, 3, 4, 5. So how do we find expected count? They gave us some hints where we can actually see what are the proportion. Do you guys see the hint here? Is it visible to you? They're asking, are the groups evenly distributed? What does that mean? Any comments? No comments from anyone? Okay, let's say, let me ask you a real life scenario. Let's say you have 5 candies. You wanna divide them evenly into 5 people. So how many candies or candy one of each will get? Tao have an answer. Good job, Tao. So they're evenly distributed. It means whatever quantity we have, we are gonna divide them evenly into 5 categories. So if you wanna divide evenly into 5 categories, all you have to do is divide 352 by 5. Then whatever we have the same number of people under expected count, each of the expected count. That's what I said. They did not give us the proportion directly, but they gave us some hint. We want to see if they're evenly distributed, evenly split. So honey, 355. What do we get? 5 goes to 35 7 times. And then 5 goes to 2, so 70. And then we're left with 20. No, not 20. How much we have? 350 divided by 5? 4. Okay, right. 70.4. So each one of them are 70.4. That is what we expect to have. In reality, we don't, because for the first one, we have 52. Second one, 63. Then 64. Then 99. Then 74. So this is the reality, what we observe. And expected count is what we expect to have, or what you want to have. So we don't need to do expected count 5 times. We do it only once, and we write it down under each category, because we are evenly splitting our 352 people into 5 groups. So we have observed minus expected. So 52 minus 70.4. We square the quantity and we divide by 70.4. We do the same thing for each one of them. 63 minus 70.4 square, and then we have 70.4. So keep doing it. And then I think my answer is wrong. So give me the answer, guys, please. What do we have for each one of them? So we do this. We subtract the right from the left, and we divide it by right. The faster you do, the faster I will be done in this question. 4.809. 4.809. The next one. Thank you, Fatima, Ilazi, Queenie. 0.77, let's say 8. The next one. 0.58, let's say 2. 11.618, and you have last one. 619. Okay. 0.184. Now you're gonna add all of this. This plus this plus this, and this. How much we have? 11, 13, 14, 15, 17. Okay, 17.972. So we are done with the statistic. Chi-square statistic is 17.972. Now we need to find chi-square critical. So alpha, they gave us 0.05. 0.05. What is the degree of freedom this time? Good job, Xian. It's 4. Because we have 5 categories. So 5 categories minus 1 gives us 4. So 4.05. Now 4 is here. 0.05 is here. 0.05 and 4, 9.488. 9.488. Carry out the hypothesis test. The critical is smaller than stat. So we reject. Good job. We reject the null hypothesis. So null hypothesis says they all are equal. We are rejecting that idea. So the conclusion we make is they're not equal. We have enough convincing evidence. So all of these numbers are wrong. Let me try to fix them. This is 4, 4, 4, 4. Since we are rejecting the null hypothesis, so we have convincing evidence at the alpha level 0.05 to conclude that the proportion all are not same. So make sure you know how to write the conclusion. Conclusion has a point, so every part has a point. In the exam, chi-square statistic will have a point, probably 2. chi-square critical probably will have two stating this is called carry out reject or fail to reject. So probably this will be 2 points, and stating a conclusion will be 2 points. And filling out the entire table will have each 1 point for each blank space. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then probably this is 1. Okay. So you need to know how to state the conclusion, how to find each expected count, how to find observed minus expected square over expected, how to find critical value, all of this. Any question? No question. P-value is, we need a calculator or some type of internet to find the p-value. That's why I didn't show you the p-value methods. But in the homework, if they're asking for p-value, you're going to go to Google and type p-value calculator for chi-square, and then they'll give you the p-value. Finding p-value from a table is harder. So I don't like that. So that's all will be in exam 2. We have one more thing to discuss in chapter 12, but I'm going to show you after the exam because I'm not going to put this in the exam. Okay. So any question on chapter 12?
How do you know when it's failed to reject?
It's the same conclusion. If critical is bigger than stat, we fail. But if I have this written here, why am I down? Look at the information. If critical is smaller or equal than the statistic, and statistic with a plus sign, we ignore the minus sign, then we reject the null. But if critical is bigger than the statistic, the plus sign of the statistic, then we fail to reject.
Oh, okay, I see. I didn't catch that first part in the beginning. That's why. But thank you for
It's true
explaining.
for, no problem. It's true for any type of hypothesis test. Either you do p-value, either you do t distribution or z distribution or chi-square distribution. It doesn't matter which one you do. They all have the same rule. If the critical is smaller, we reject. But if the critical is bigger, we fail to reject. And if you're working with p-value, then if p-value is smaller than the alpha, we reject. But if p-value is bigger, then we fail to reject. P-value is bigger than alpha. You should actually know these. We're not going to use it in the exam, but you should also know this. Okay. Now let me tell you what you should expect. No, chapter 5 will not be here. What you expect to have in your fill in the blank type of question. So if you go to the beginning of the recording of chapter 9, 10, 11, 12, you'll see that there are many sections where I said, make sure you know this. On top of my head, I remember about best statistic, best point statistic, something like this. I don't remember clearly. What was that? Statistic. What is the best statistic? Best point statistic? Something like that. What is the best point statistic for population mean or population proportion? And then what is one of the example of bias statistic? Statistic. What is one of the example of unbiased statistic? Statistic. What's the relationship between confidence level, alpha, which is significance level, and confidence interval? What's the relationship between them? And also p-hat. They have some relationship between them. What are the relation between them? What is type 1 and 2 error? What else? I don't remember this clearly, but please go over all the lecture videos and see when I say this is a good thing to discuss, then make sure you know those. Also, another thing is when degree of freedom for T gets bigger, means the more degree of freedom you have, it becomes a Z distribution. So T distribution is for smaller sample size, but if your sample size has many people, it becomes a Z distribution. I discussed that. What else I talked about? Today I talked about two types of chi-square tests. So two types of chi-square tests. What are the type? When do you use each type? What else? Things like this, okay? There could be few other things. I don't remember exactly. But these are the basic things. So you should know this for fill in the blank, true false type of question. They have more, okay? I just don't remember them. But I'm telling you, like each video I told you, like from each section, from each chapter, what could be a good question from that chapter for the exam. Chapter 9 has 3 things: proportion, t-test, and z-test. I'm going to ask 2 questions from here. 2 questions combined in 1 question. So how do you distinguish which one to use? You observe something. If you're given a fraction in the sample, it means it's p-hat. If you have a portion in the sample, it represents p-hat. And if you're working with p-hat, that means that's the formula you have to use. So make sure you have this formula written down. Also, what each symbol means. What is p-hat? What does it mean? And how do you find z critical value? So for z critical value, you don't have to find it manually. If you have your table, the table I already gave you here. So make sure you have this table. If you are working with one tail, these are the critical value we have based on the alpha level. If you are working with 2 tail, these are the numbers you have to work with. So confidence interval, anytime you work with confidence interval, they always use 2 tail Z. Okay. If you are working with proportion, they use Z, they never use T. Proportion means Z. And how do you know one till or two till? One till means you're working with one-sided hypothesis, and two till means you're working with not equal. For example, do they have any effect on something? So if you don't know what this effect means, is it increasing or decreasing? You don't know. That's two-sided. But if they mention about increasing or decreasing, it's one-sided. Um, So yeah, proportion. Yes, I'm going to give you all the table. The Z table, T table, chi-square table, all of these will be given to you. You don't have to print out anything except for your cheat sheet. So make sure you know how to interpret your confidence interval. So for proportion, if you're working with proportion, this is the formula you have to use. The Z is always two-sided. Always. And proportion means Z. So these are the solution I have on the right side. And based on in a data set, if you are given population standard deviation, then you use Z because they have population standard deviation. But if you are not given population, you're given sample. See here, it's just a sample mean with a standard deviation. So this is sample standard deviation. If you're given sample standard deviation, that means you are working with T. For confidence interval, it's two tail, always. And make sure you know how to interpret your table. When you interpret the table, there are three main things. One is your percentage. If they're asking you to construct a 90% confidence interval, it means you are 90% confident. If they want you to construct a 95% confidence interval, it means you're 95% confident that the true mean of the population falls between whatever number you found. Okay. And in whatever scenario you're working with, it doesn't matter which scenario you're working with. The main idea is you are that percent confident, then the true mean of the population will fall between the two numbers you found. So chapter 9, you're going to have two of these. One is either from T or Z, and one from the proportion. Okay. Then chapter 10, again, it has three scenarios, either proportion, Z or T, but this time you're doing hypothesis test. But it follows the same rule. If they give you some information about fraction or percentage, it means proportion. So fraction or percentage means proportion. If you're working with proportion, that's the proportion formula you need to use. So P hat is based on sample. Let's say this one, they're saying you have 1,000 women and 560 indicates some characteristic. So this 560 is among this 1,000. So this is a proportion of sample, 560 over 1,000. And then if you have population standard deviation, you're going to use Z. If it's sample standard deviation given to you, you use T. And the Z formula is this. Z and T, they have the same formula. The only difference is that Z has a sigma on the denominator, where T has a sample standard deviation on the denominator, but they have the same formula, everything. Hypothesis value, we get it from the hypothesis. Get it from the null hypothesis. Null hypothesis will always be based on population parameter. This is another thing you should know. I forgot to mention. Hypotheses are always not based on for, always for population parameter. Means you're going to use either mu or p. You cannot use x bar or p hat. You must use mu for population mean or p for population standard deviation. So all these questions, I believe I went over in class. So if you want to see the solution, you need to just look at the lecture notes. Now, chapter 11, it compares to population treatment. But to make your life easier, I'm telling you that I'm going to give you paired sample t-test. It means something like this one, the right page. There will be a raw data set given to you. You need to find the differences. So you subtract. See here, I already told you, each mean is what? So mu A means the mean for this data, and mu B means it's the mean for before data. Now, to find mu D, so if you are confused what is mu D, no problem. You work in traditional way. Mu after and mu before are equal. And then from here, your hypothesized value will be 0. Hypothesized value. Why? Because of this. And then this symbol will be based on the scenario given to you. In here, they are asking is a significant evidence the lecture videos are effective. So effective means positive. So is it, do we have enough evidence to say that these videos are positively affecting the students? So that's why mu after is bigger than mu before. In other words, our difference is a positive difference. But we have also other scenarios. It could be less than, or it could be not equal. So if you're doing increasing, decreasing, those things, it's one-sided. But if you don't see the increasing or decreasing word, or like it can't determine which side you're working with, it's two-sided. For example, if they said, does it have any effect on something you're doing? So for any effect, you have no idea. Is it affecting positively or if it's affecting negatively? So if you have no idea, it's two-sided. But in here, it's clearly I'm mentioning that I want to see whether my videos help them or not. And since we are doing differences, so we need to find the x bar of the differences, standard deviation of the differences. So make sure you have this written in your cheat sheet, the formula for the standard deviation. And since you're working with sample, small sample, so we are going to use t-distribution. And this time it will be one sample t-distribution. We find the critical value based on degree of freedom and alpha level. If it's one-sided, then it's one tail alpha. And if it's not equal, then it's 2 tail alpha. And in the table, you will see 1 tail alpha and 2 tail alpha. And if they don't give you the alpha, they will definitely give you the confidence level. So remember, alpha is 1 minus confidence level. If they didn't give you alpha, then you have to find it based on confidence level. And then you go into a chi-square. So chi-square, I already told you what to do in a chi-square. And that's it. So this exam will be hard if you have no idea what's going on. If you cannot distinguish what is given. Sample, standard deviation or population, standard deviation or proportion. If you cannot figure that out, then you'll be in trouble. But if you can figure this out, then you'll be fine, I think. Any question, comments, concern, complaint, anything? If you have any question, make sure you have a calculator. There are many things you have to do in the calculator. After the exam, I'm going to go about rest of the chapter 12, chapter 5, and the department told us to go over chapter 15. So I'm going to go over chapter 15. So we still have 3 things to discuss, and then we have our final exam. This review slide, the review slides are posted on Blackboard. So you can actually see them on Blackboard. Okay. Anything else? If you have any question, you can email me anytime. Okay. Otherwise, you're done. Okay, guys?
Would you say it would be better to like mainly focus on the review sheet for practice?
Yeah, the question will be very similar to the review sheet.
Okay.
But also take a look at the homework question for true, false, fill in the blank type question.
Okay.
Okay then. Goodbye, everyone. That's all for today. Good luck with your exam. Try to come early. Don't be late. If you come early, you can start early.
For the true, false, and filling the blank, which unit will we mainly be on so I can look over the homeworks?
9, I don't remember exactly, but during every lecture, I told you, like, this is a good topic. So,
Oh, the exam, like the highlights ones,
so
right?
here I see chapter 9 the most.
Okay.
So the most will be from chapter 9,
Okay.
and
Thank
then
you.
10, and then 11, and then 12.
Okay. Thank you.
Okay, everyone. Have a good weekend. Have a wonderful night. Thank you. Thank you, guys. Thank you. Bye-bye.